All right, since this lesson was super important, I'm going to go ahead and do a video lesson. We had quite a few people out, or you might just need to watch it a second time. So what we're going to be talking about today is writing polynomials using the fundamental theorem of algebra. So the fundamental theorem of algebra is pretty important. It kind of helps us understand this relationship between our roots, the answers to a polynomial, and the polynomial itself. So the fundamental theorem of algebra says that all polynomials have the same number of complex zeros or complex roots as the degree of the polynomial. So for example, if I have the polynomial x cubed plus 2x squared minus 7 equals 0, what that's saying is this is a polynomial with a degree of 3. That's the exponent of the leading term. And it's telling me that it has 3 complex zeros or 3 complex solutions. Now, those solutions can be real solutions. So, for example, x equals 7. That's a real solution. It could be a rational solution. Rational solutions, 7 could also be a rational solutions, but really we're talking about maybe fractions. So x equals negative 2/3. That would be a rational solution. We'd be able to see that on a coordinate plane. It's just a fraction. Rational numbers are just numbers we can write as fractions, decimals, or percents. It could be an irrational solution. We can also see irrational solutions on a coordinate plane, but that might be an example would be x equals plus or minus square root of 2. And then lastly, we have these imaginary solutions. Now, an irrational solution could be seen on a coordinate plane, but an imaginary solution cannot be seen on a coordinate plane. So maybe x equals plus or minus 3i. So notice that both irrational and imaginary solutions have that plus or minus, and that's going to be really key as we move forward. So those are some examples of complex solutions. When we're talking about repeated factors represent zeros with something called multiplicity. What multiplicity means is it's just how many times a polynomial has a solution or a zero at a given point. That's the multiplicity of that root. And we will talk about it a little bit more when we get to graphing, writing polynomials with graphs. But just really quickly, if I look at this graph over here, this graph crosses the x-axis 3 times. Each one of the times that it crosses the x-axis, that's just a multiplicity of 1. It's called a cross. So we'll talk about other multiplicities as we move on. All right, the way that we go from a solution to a polynomial to writing that polynomial is this. We set each root equal to x. And then keep in mind that imaginary numbers and radicals always come in these plus or minus pairs. Next thing we're going to do is get each equation equal to 0. We're going to make those factors. We're used to looking at the polynomial and factoring it. Now we need to create those factors. Our factors are always equal to 0, so we have to create that. Next thing we're going to do is we're going to multiply those factors and expand. And then we're going to write the polynomial always in standard form, which just means your exponents are decreasing. They're going down. So let's give this a shot. We're going to start out easy and go harder. So given the roots, write the polynomial equation in standard form. So we're given the answers. We have to go back to the question, to where we started. So we're going to follow those steps that we just looked at. Set each root equal to x. So x equals negative 3 and x equals 4. Next thing we do is we get those factors equal, or we get those roots equal to 0. So x plus 3 equals 0 and x minus 4 equals 0. Now I can get there one of two ways. I can either just bring that negative 3 across the equal sign and change the sign. That's what I did. Or I could add 3 to both sides. Either way, I'm going to end up with the same answer. So if you bring a number across the equal sign, you have to change it to its opposite. So now I have my factors, x plus 3 and x minus 4. So I'm going to go ahead and write those as factors, x plus 3 times x minus 4. And I need to set that equal to 0. It's an equation now, it's a function. So I need to make sure I have it equal to 0. And then I'm going to multiply that out to get the polynomial in standard form. So x times x is x squared. X times negative 4 is negative 4x. 3 times x is positive 3x. And 3 times negative 4 is negative 12. And all of that's equal to 0. I'm going to simplify. X squared minus x minus 12 equals 0. What I'd really like you to do right now is pause this video and graph this function in Desmos and make sure that you see where this function crosses the x-axis at negative 3 and positive 4. Another way we could write this is y equals x squared minus x minus 12. These two things mean the same thing. All right, let's do it again. This time I have 3 roots, so it's getting more complicated. I'm going to go ahead and set those roots equal to x. So x equals negative 3, x equals 0, and x equals 1. I'm sorry, I need to set those roots equal to x and then set those equal to 0. This one's going to become x plus 3 equals 0. This is still x equals 0. And the last one is x minus 1 equals 0. Again, just bringing that number across the equal sign makes it the opposite sign. So I have 3 factors. I'm going to go ahead and put those factors in a way that I'd like to see them. I like x up front, x plus 3 times x minus 1, and all of that's equal to 0. Now, when we were factoring, we've seen this before when we were factoring and solving. So this isn't new, we're just working backwards to get to the polynomial. So now I need to multiply this out. X times x is x squared, x times 3 is plus 3x. And then what I'm going to do is say I've taken care of those two. Now I need to remember to multiply that times my last factor, x minus 1. So now this is a binomial. X squared times x is x cubed. X squared times negative 1 is negative x squared. 3 times x squared is plus 3x squared. And 3x times negative 1 is 3x, negative 3x, sorry, equals 0. I don't have, oh, sorry, I missed that squared. 3x times x is 3x squared. Now I'm going to combine like terms. X cubed plus 2x squared minus 3x, sorry, equals 0. And that's my final answer. And again, I'd like you to pause the video and graph this in Desmos and see if you see a cubic, it's cubic, that crosses the x-axis at 3 different places that you can see at x equals negative 3, x equals 0, and x equals 1. All right. So sorry, I'll tick on my throat. The next one I have is negative 2 with a multiplicity of 3. So multiplicity, again, is those repeated factors. So if they say there's a multiplicity of 3, that means I have x equals negative 2, x equals negative 2, and x equals negative 2. I have that 3 times. It's going to look weird on the graph when you graph this one. I definitely, when we're done, want you to graph it so you can see it looks different. Just means we have the exact same factors 3 times. So I'm going to have x plus 2 equals 0, and I'm going to be multiplying that 3 times. So x plus 2 times x plus 2 times x plus 2 equals 0. Now I like to chunk my multiplication, so I'm going to do the 2 back factors. I'm going to do those first and then multiply that times the front one. So I'm going to keep that x plus 2, and I'm going to go ahead and multiply these. This is x squared plus 2x plus 2x plus 4 equals 0. I'm going to go ahead and combine them. I have a nice eraser. I'm going to go ahead and combine these two into plus 4x. A lot of you are doing that multiplication in your head. You already had the plus 4x. I'm going to go ahead and just simplify that because 2x plus 2x is 4x. And now I'm going to multiply this binomial times this trinomial. I should end up with 6 terms. It's going to get a little messy. Just be careful. X times x is x. X times x squared is x cubed. X times 4x is 4x squared. X times 4 is plus 4x. 2 times x squared is plus 2x squared. 2 times 4x is plus 8x. And 2 times 4 is plus 8. And that equals 0. It could also be equal to y. Now go ahead and combine like terms. X cubed. I've got 4x squared plus 2x squared is plus 6x squared. I have 4x plus 8x is plus 12x. And I have plus 8, and all of that's equal to 0, or it's equal to y. When you do the delta math practice, you want to say it's equal to 0. It doesn't seem to like equal to y. All right, let's go ahead and get some rational solutions. I have x equals negative 1/2, x equals 0, and x equals 3. X equals 0, that's the easiest one, so I'm going to go ahead and write it first because it's done. That's my factor x. It's already said equal to 0. X equals 3 is the next easiest one, and then that x equals negative 1/2, that's the toughest one. So right now my factors are x. I've got x minus 3 equals 0, so x times x minus 3, and then I'm going to have to figure out this last one. So in order to change this fraction into a factor, I'm going to have to get rid of that 2 on the bottom of that fraction. So I'm going to multiply both sides by 2, and I get 2x equals negative 1. And I'm going to add 1 to both sides. 2x plus 1 equals 0. And there's my third factor. I'm going to go ahead and add that to my polynomial. And I'm going to multiply this out to get a polynomial in standard form. X times x is x squared. X times negative 3 is negative 3x. And I've taken care of that. I'm going to go ahead and take this binomial and multiply it by the second binomial. Again, I like to chunk things so that it doesn't get too messy. X squared times 2x is 2x cubed. X squared times 1 is plus x squared. Negative 3 times 2x is negative 6x squared. Negative 3 times positive 1 is negative 3x. And all of that's equal to 0. Let's make this one equal to y, just something different. I'm going to go ahead and combine my like terms, and then I'll be done with this one. So y equals 2x cubed minus 5x squared minus 3x. And then I have a polynomial. I would love for you to pause this video and graph that in Desmos and see where this one crosses at negative 1/2, 0, and 3. That is one way that you can always check your answers if you have access to Desmos. We're going to do one more, and then I'm going to give you a chance to practice. Number 5 says negative 3/4 and 2/3. So we only have 2 factors. And according to the fundamental theorem of algebra, that means I should end up with a polynomial that is x squared. So let's see how that works. X equals negative 3/4. X equals 2/3. I'm going to go ahead and multiply both sides by 4. And I get 4x equals negative 3. I'm going to add 3 to both sides, so 4x plus 3 equals 0. That's my first factor. Over here, I'm going to do the same thing, times 3 times 3. 3x equals 2. I'm going to subtract 2 from both sides, and I get my second factor. Once I have those 2 factors, I'm going to multiply them. 4x plus 3 times 3x minus 2, and that equals 0. It could be equal to y. I'm going to multiply that binomial. 4x times 3x is 12x squared. 4x times negative 2 is negative 8x. 3 times 3x is plus 9x. And 3 times negative 2 is negative 6. And all that's equal to 0. And go ahead and finish this up and notice that I do have a polynomial where it's a quadratic. So it's x squared. I had two solutions and there are two solutions I can see on the graph. 12x squared plus x minus 6 equals 0. If I put that into Desmos, I should be able to see my solutions because they're all real solutions. So what I'd like you to do right now is go ahead and pause the video and go to Delta Math and go ahead and do this check-in. It just has you do like 5 problems just like these with no fractions, just to practice this skill before we move on. All right, now that you've got that under your belt, let's go ahead and talk about the conjugate root theorem or the imaginary root theorem and how that can help us. So a conjugate pair is a pair of terms that have different signs. So same numbers, different signs. So for instance, a plus b and a minus b. Those are conjugate pairs. They have different signs. And the way that they can be helpful is those middle terms tend to cancel out when we use addition and multiplication. So for instance, if I'm going to find the sum of a plus b plus a minus b, that positive b and that negative b, they cancel. So I just end up with two a's because b minus b is just 0, but a plus a is 2a. So that's kind of nice. And then same with the product. If I multiply a plus b times a minus b, it looks like this. A times a is a squared. A times negative b is negative ab. B times a is positive ab. And then b times negative b is negative b squared. So that all simplifies because I'm getting rid of this negative ab and this positive ab. It simplifies to a squared minus b squared, which you've seen before. That's the difference of perfect squares. A is a perfect square, b is a perfect square. And we always change it to that when we're factoring. So conjugate pairs, that's kind of how they work. Same terms, different signs. So where we see this a lot when we're writing polynomials is with imaginary numbers. So something like a plus bi and a minus bi, those are conjugate pairs because we have one addition, one subtraction. They always show up in pairs, and also irrational roots. So a plus the square root of b always has a pair, and that pair is always a minus the square root of b. So the important takeaway from this, what we have to remember is irrational and imaginary roots always come in pairs. So even if you don't see the pair, you have to know that it's there. So for instance, if they say the square root of 7, you have to know that there's also a negative square root of 7. You have to be able to add that. If they say one of your solutions is negative 5 plus 7i, you have to know that it's also negative 5 minus 7i. So you have to be able to do that. All right, the first two that I'm going to do with imaginary or irrational solutions, I'm going to show you just a real quick and easy way to make the polynomial. And this really only works if you have a very simple imaginary number. So no real numbers with this imaginary number. You're not going to see it very often, but I want to show you this. This is not how pre-calc is going to be. They're going to have more complicated roots, but I want to kind of step you into this so you're not overwhelmed. So I'm given two roots, 4 and 2i, and I'm supposed to write a polynomial that would give me these roots. So first thing I have to do is I look at that 2i and say, oh yeah, he has a partner. He has negative 2i. So he's made up of positive 2i and negative 2i. Have to remember that. Second thing I do is what I've been doing the whole time. X equals 4. And I'm going to go ahead and say this time x equals plus or minus 2i. So with my x equals 4, that's very easy to go to my factors x minus 4 equals 0, and I've got my factor. With x equals plus or minus 2i, there's a lot of different ways you could do this. This, I'm just letting you know, is the easiest way if you have a very simple situation like this. What we do is we go ahead and square both sides. So that gives me x squared equals, and then I'm going to raise 2 to the second power and I to the second power. Well, 2 to the second power is 4. I to the second power is I squared. I don't have to worry about that plus or minus because when I square a positive, positive 2 times positive 2 is positive 4. But if I square a negative 2 times a negative 2, it's also positive 4. So I'm kind of taking care of the same thing in one job. Keep in mind that I squared is always equal to negative 1. So I'm going to replace that I squared with a negative 1. So x squared is equal to negative 4. I'm going to set that equal to 0. X squared plus 4 equals 0. And there's my second factor. Now notice I have 3 solutions, 3 roots. I should end up with a cubic. So let's see if I do. I'm going to put the x squared plus 4 up front times x minus 4, my second factor, equals 0. I'm going to go ahead and multiply those two binomials and see what I get. X squared times x is x cubed. X squared times negative 4 is negative 4x squared. 4 times x is plus 4x. And 4 times negative 4 is minus 16. And all of that is equal to 0. There's nothing to combine. It's a 4-term polynomial. And it is a cubic, which tells me that I have 3 solutions. In this case, when I graph this, so please pause and graph, I'm only going to see one of those real solutions. I'm going to see it at x equals 4. But there are 2 other solutions. They're just imaginary. Cannot see them on a graph. All right, let's try number 7. So number 7 is kind of the same situation. Still very simple roots. The first one's real simple. X equals 2, which turns into x minus 2 equals 0 as my factor. And then I've got negative square root of 3. I have to remember that negative square root of 3 has a partner, the square root of 3. So in order to get to my polynomial pretty quickly, I'm going to say x equals plus or minus the square root of 3. I'm going to go ahead and square both sides. And I'm going to end up with x squared equals, and I'm going to raise the square root of 3 to the second power. So that means the square root of 3 times the square root of 3, which equals the square root of 9, which is actually just 3. So my answer here is x squared equals 3. I'm going to go ahead and set that equal to 0 to get my factor of x squared minus 3 equals 0. I'm going to multiply those out to get my polynomial. I should have a cubic because I have 3 solutions. I will be able to see all 3 of these solutions on my coordinate plane. The square root of 3 is a number. The negative square root of 3 is also a number that we can actually see. So I'm going to put x squared minus 3 up front times x minus 2. That's equal to 0. X squared times x is x cubed. X squared x squared times negative 2 is negative 2x squared. Negative 3 times x is negative 3x. And negative 3 times negative 2 is positive 6. And all that's equal to 0. Again, nothing to combine, so I am done. I could also say y equals all of that. It's a cubic. Go ahead and graph that. And now we're going to move on to how you're actually going to use this and apply this. Well, actually, I'm sorry. Just really quickly, I want you to do some operations with imaginary numbers. I want you to practice adding and multiplying. So you're going to go back to Canvas. You're going to find the assignment that says 926, adding and multiplying complex numbers. And I'm going to show you a quick example. We practiced that. The multiplication is more important than the addition. The addition that we're going to do is going to be super simple, with the multiplication will be more complicated. So for example, if I said I've got 3 plus 7i, I'm going to take that and add that to 2 minus 5i. It would give me a solution of 5. I'm going to add my reals. 3 plus 2 is 5. And then I'm going to add my imaginaries. They can't go together. So I'm going to say plus 2i. So remember we talked a little bit about that where this is a plus bi, and a and b can't go together. Now if I'm going to multiply those same two, I'd say 3 plus 7i times 2 minus 5i. So 3 times 2 is 6. 3 times negative 5i is negative 15i. 7i times 2 is positive 14i. And the last one's going to be negative 35i squared. So we're going to simplify. I've got 6 minus I. And then this negative 35i squared, well, negative 35 times negative 1, remember I squared is the same as negative 1, is going to give me a positive 35. Not quite done until I put this 6 and combine it with this 35. So 35 plus 6 is 41 minus I. So that's our final solution. So again, practice the multiplying more than the addition, or you can do them all. All right, we're jumping back in. In pre-calc, you are going to learn how to do this with, these are more complicated roots. And so we use something called the sum and product of roots theorem. And this can be used with all the conjugate roots. So it could have even been used with that 2i and negative 2i. Those less complicated ones, we would use it there. So I'm going to explain what it is and how you get there. So the sum and product of roots theorem is kind of a formula. It goes like this: x squared minus the sum of our conjugates times x plus the product of our conjugates. And that's going to be equal to y or equal to 0. So when we have conjugate roots, there's always two of them. It's a pair. That's how we end up with x squared. That's how we end up with a quadratic. This sum refers to the sum of the conjugates. So we're going to take those conjugates and add them together, the plus and the minus. And it also, the product refers to the conjugates as well. So what I think the biggest thing we have to remember is we always get x squared up front. We're always using the opposite of the sum times x, and then we're always adding the product of the conjugates at the end. So let's go ahead and do it. So I have 3 minus 2i. Well, I know if I have 3 minus 2i, I also have 3 plus 2i. They travel in pairs. So what the sum and root theorem says is I'm going to find the sum of my conjugate pairs. So 3 minus 2i plus 3 plus 2i. And I'm going to figure out what that's equal to. So I know 3 plus 3 is 6, and negative 2i plus 2i, well, those cancel. That just gives me 6. I'm going to end up with a nice whole number. So I'm going to go ahead and start building my polynomial down here in the corner. I've got x squared. I'm going to have the opposite of the sum of those conjugates. The sum was 6. I'm going to multiply that by x because that's really my b value in my quadratic. And then I'm going to be adding that to the product. So far, this is what I have. Next thing I'm going to do is I'm going to find the product of those conjugate pairs. So 3 minus 2i times 3 plus 2i. And I'm going to have to multiply those binomials. So 3 times 3 is 9. So I did 3 times 3. 3 times 2i is plus 6i. Negative 2i times 3 is minus 6i. We're going to see every single time that these middle, this is the beauty of conjugate roots, these middles, the yucky stuff is going to cancel. And then negative 2i times positive 2i is negative 4i squared. So my positives and negative I, they disappear. This is negative 4 times negative 1, which is positive 4. So I'm going to be adding 9 plus 4 to get 13. So I'm going to finish out this new quadratic. I'm going to say x squared plus 6x, or I'm sorry, x squared minus 6x plus 13 equals 0. Now I can graph that all I want, but you're not going to see it cross through the x-axis. Please graph it. You're going to see that it's going to graph like this, where the never crosses the x-axis. Something like that. I don't know where it falls exactly, but that's what it looks like. All right, let's do it again. So this one is a irrational. -1 plus the square root of 3 is going to give me an irrational. And it has a conjugate. So it has a pair. If I have -1 plus the square root of 3, I also have -1 minus the square root of 3. Irrationals and imaginaries travel in that plus or minus pairs. So I'm going to use the sum and product roots theorem, which says that x squared minus the sum of the conjugates times x plus the product of the conjugates equals y or equals 0. So I know I'm going to have x squared. I don't know why I'm using parentheses. How do I go? I have x squared. And then I'm going to figure out the sum of -1 plus the square root of 3 plus -1 minus the square root of 3. So -1 plus -1 gives me -2. Square root of 3 minus the square root of 3 gives me 0. So now I've got -2. Well, right here it says I have to use the opposite of this sum. So the opposite of -2 is +2. We're going to add an x onto that because it's a b value, it's not a constant. Now I'm going to find the product of -1 plus the square root of 3 times -1 minus the square root of 3. So I have -1 times -1 is going to give me +1. -1 times negative square root of 3 is going to give me positive square root of 3. Square root of 3 times -1 is going to give me negative square root of 3. Those middle terms are going to cancel. And then the square root of 3 times negative square root of 3 is going to give me negative. And then again, square root of 3 times square root of 3, square root of 9, which is equal to 3. So middle terms cancel, and I end up with 1 minus 3, which is -2. So I'm going to finish out my quadratic with x squared plus 2x minus 2 equals 0. And that is the quadratic that goes with these roots. Those roots right there. And we would be able to see those. Go ahead and graph this, please. It's going to be a quadratic where it does cross the x-axis. Irrational numbers are visible on your xy coordinate plane. All right, number 10. We're going to do the exact same thing, except now we've added in a real number as well. So we're going to have 3 solutions or 3 roots, because as we know, 1 plus the square root of 5 always has 1 minus the square root of 5 with him. They travel in pairs. So we have 3 roots, which means 3 solutions, which means a cubic polynomial. I'm going to start with the easy guy first. I'm going to say, well, x equals -1. So x plus 1 equals 0, and that is my first factor. So I'm going to put him down here, x plus 1, just like that. Now I'm going to find my quadratic, by using the sum and root theorem. So that says x squared minus the sum of the conjugates times x plus the product of the conjugates, and those are equal to 0. This is going to be your next factor. We're going to have to do a little bit more multiplication after that, but we got this. All right, so the sum of 1 minus the square root of 5 plus 1 plus the square root of 5 is going to be equal to 2. So down here, I've got x squared. I'm going to use the opposite of 2, which is -2x. And then the very last term that I need is the product. So the product of 1 minus the square root of 5 times 1 plus the square root of 5. If you're okay with it, I'm not going to put those middle terms in there this time because I know they cancel. So 1 times 1 is 1. The square root of 5 times the square root of 5 is the square root of 25, which is actually 5, and it's not positive, it's negative because I'm multiplying a negative times a positive. So I'm going to get negative 4 as my product. So to finish out this polynomial, I've got x squared minus 2x minus 4 equals 0. Not quite done yet. I need to go ahead and multiply this binomial times this trinomial. I should end up with 6 terms. A lot of room to make mistakes, so just be careful. I will multiply x times x squared is x cubed. X times negative 2x is negative 2x squared. X times negative 4 is negative 4x. 1 times x squared is plus x squared. I've got negative 2x and then negative 4. Now that's equal to 0, so I have 6 terms. I'm going to go ahead and combine like terms. I'm going to double check, just double checking my answer key to make sure I'm on track. All right, so I've got x cubed up front. I had 3 solutions. That looks good. I have negative 2x squared plus x squared. That should give me negative x squared. I like to cross my things out so I know that I'm keeping track of them. Negative 4x minus 2x is negative 6x. And negative 4. No, that's equal to 0. So if I were to graph this polynomial, it would be a cubic. It would cross the x-axis, and I could see that 3 times. I could see it in all 3 of those places, at all 3 of those roots, because a rational is visible on your xy coordinate plane. All right, number 11. This is the last one we're going to do, and then that covers everything we covered in class on Thursday. We'll finish this up on Monday. All right, this is the hardest one because I have an imaginary root and I have an irrational root. And so I'm looking at 2 roots, but there's actually 4 here, which means I'm going to end up with a 4th degree polynomial, x to the 4th power. So I know that 2i comes with a negative 2i, and 2 plus comes with 2 minus. So 2 minus 2 squared root, that's a lot of 2's. All right, this is a conjugate pair, and this other one is a conjugate pair. So I'm going to have to do that sum and product thing. I'm going to have to do it twice. I'm going to be building 2 different quadratics. It's going to be a little messy. Actually, it turns out to be a binomial. Yeah, there's still quadratics, 2 different quadratics. All right, so I'm going to do negative 2i and positive 2i first. So the sum of negative 2i plus 2i turns out to be equal to 0. So as I build my polynomial down here, I'm going to have x squared, and the opposite of 0, it's just 0. So there is no b term. That's cool. The product is going to be negative 2i times 2i, which is negative 4i squared, which we know makes positive 4. This is negative 1 times negative 4 is positive 4. So I'm going to be adding 4 because I always add the product. So there's my very first quadratic. I'm going to go ahead and write the sum and product roots theorem up here. X squared, the opposite of the sum of the conjugates times x plus the product of the conjugates equals 0. All right, now we're going to do the sum and products with this other guy. So sum of 2 minus 2 square root of 2 plus 2 plus 2 square root of 2 equals just 2 plus 2, which is 4 because these last terms cancel. So I'm going to go ahead and start this quadratic. X squared minus 4x, the opposite of that x. And then I'm going to go ahead and do the product to get the last little bit of this. 2 minus 2 square root of 2 times 2 plus 2 square root of 2. That equals 4. My middle terms cancel, so I just have to multiply the last terms. So 2 times, so this is minus because it's a negative times a positive. 2 times 2 is 4, and the square root of 2 times the square root of 2 is going to be 2. So I'm going to follow the order of operations. 4 minus 8 is negative 4. So this one turns out to be x squared minus 4x minus 4. The last thing I'm going to do is go ahead and multiply that all out and get my final polynomial. Again, messy. This is where you're going. There's the big problems. So x squared times x squared is x to the fourth. X squared times negative 4x is negative 4x cubed. X squared times negative 4 is negative 4x squared. 4 times x squared is positive 4x squared. Positive 4 times negative 4x is negative 16x. And to finish this out, 4 times negative 4 is negative 16. And all that equals 0. For my final polynomial, it is to the fourth power. We had 4 roots. 2 we would be able to see on the coordinate plane. 2 we would not. So we're going to say x squared. I'm sorry. Just kidding. X to the fourth power minus 4x cubed. There's no other cubes to combine with. This negative 4x squared and this positive 4x squared, that makes 0. So minus 16x minus 16 equals 0. And that is our final polynomial. So you will be able to do part of the homework, but not the graph part of the homework. We're going to work on that on Tuesday, but I wanted you to have all this information if you were absent or if you just needed to see it again at your own speed. Let me know if you have any questions. Thanks.